Welcome back to another one of my applications of differentiation videos. We'll be focusing on maximas and minimas. This is the third episode. And we'll be focusing on a bit more complex, or a more complex function than my other two previous videos. One hopefully you haven't seen before, or haven't seen of. Anyway, let's get right into it. So, as usual, we get a function, and the function will be square root of x over 1 plus x, and it'll be within the domain of 0 and 10. Okay, so basically we're going to get the function, derive it, find critical numbers, and then use those critical numbers to find critical points, and then use those critical points to find maximas and minimas, or extremas, or minimums and maximums, whatever you want to call them. That's what we'll be finding. Okay, so as I said, first step is to find the derivative. Now we have a function over a function, therefore u over v, quotient rule. So it'll be u dash v minus u v dash over v squared. And I'm just going to fill this out, like the derivative of a square root of x is half multiplied by x to the power of negative a half, multiplied by v, which is just 1 plus x, minus u, which is the square root of x, or x to the half, and multiplied by the derivative of v, which is just 1. All over v squared, which is 1 plus x squared. I'm not going to simplify it because it'll take too long. Well, I will write what I got. 1 minus x over 2 square root of x, 1 plus x squared. Now this is just simplified. When I'm going to be using this to find values, you don't really, in a way, have to worry about simplifying it down. You can just use what you have up here, and you just have more to work with. I have less to work with down here, okay? Or it's neater. But anyway, you can do the steps in between, but I got from here to here, so I don't want to take up too much more time. Anyway, so if you watch my video on critical points, or finding critical points, you'll know that finding critical numbers, what we do is we first let the derivative equal 0, which is when we're looking at the real side, which I'm not going to explain it here, but it's you basically make the top part equal to 0. And then when you let the derivative to not exist, or equal undefined, or however you want to pronounce it or say it, you basically set the bottom to 0. So you end up having 2 square root of x, 1 plus x squared. So when you set it to 0, you're finding out that x value, what x is on the top, and when you set it to undefined or does not exist, you are setting the bottom to 0. Okay? So if we have a look at this first one's easy. Basically just add x to both sides and you get x equals 1. That's our first critical number. And over here, whenever you're doing, we'll just split this up. So this will have 0 equals 2 square root of x, and 0 equals 1 plus x squared, all squared. Okay? So that's because we have two x values and we factored them out. Anyway, so here, divide both sides by 2, and you just get 0 equals the square root of x. Square both sides, and you end up with just 0 equals x. So 0 equals x, or x equals 0, is our second critical point. Okay, and over here we just square root both sides, and we end up with 1 plus x. So therefore, if we minus 1 by both sides, we get x equals negative 1. Okay. So, first, I'd like to also mention that with this function up here, I've purposely set the domain to 0 and 10. But if it was to negative infinity and positive infinity, or that was, you were just given this and told to find the domain, let's say in a question, there's a square root of x on top. That means that no value exists when x is a negative number, because if you put a negative 1 up here, let's say, it does not work because you can't square root a negative number. You can use imaginary numbers, but that's a whole different thing entirely. This right now, if you put a negative 1 in, it would not work. Therefore, this system has to start from x equals 0 and go onwards. It has to start from x equals 0 and go onwards, because if you put an x value that's less than 0, the whole thing will not work, and it won't come out. Okay, so the minimum value you can have for x is 0. Just saying. Just thought, if you ever wanted to know, or if you ever had a problem you come across, that's there. Okay. So, that's another critical number. So what we're left with critical numbers is negative 1, 0, and 1. So x equals negative 1, x equals 0, and x equals 1. And those are our critical numbers. And also in our domain, the domain is between 0 and 10, so that makes sense. Okay, the fact that it has to start on point 0, x0 makes sense there. Anyway, so we have finding critical points. We basically sub these back into the original function. So x equals negative 1, x equals 0, x equals 1, and we'll put in the x equals 10, which is the maximum x value in the domain. If we sub this back into the original function, we end up with a half, which means tick. It means that it's a critical point. At x equals negative 1 and fx equals a half, there's a critical point. X equals 0, you sub that back into the original function, and it spits out 0, which means yes. That means it's a critical point because it spat out a number. Oh, I'm sorry, I got these around. That's positive 1, and this is negative 1. I've got my my working written up. But if we, yeah, that made no sense, because I said before, if you sub in a negative number, it wouldn't work, which is what's going to happen here. If you sub this in to the original function, you get like an error, a math error. So yeah, this is the positive one, and when you sub that in, you get a half, and when you sub in a negative one, you get a math error. It doesn't exist within the domain. So therefore, this is not within the domain. This is not a critical point. It's a critical number, it's not a critical point. And over here, we have x equals 10. When you sub that in, you get, this means approximately, it doesn't mean exact, it just means approximately, roughly 0.257 or so. I'm just going to leave it at that. So yeah, that's the number, so that's a tick. So we now have critical points of x at x equals 1, x equals 0, and x equals 10. Okay? This makes sense though, these two, because these are our endpoints, a starting point and our endpoint. Okay? And that makes sense because you can't square root a negative number, because you can't square root a negative number there. Anyway, so let's do the first derivative test. with these values. So we have first derivative test. Have our x values, sub them into the derivative, and get the draw the shape down the bottom. Now, because this is an endpoint, I don't really care for writing endpoints on this because I know they're going to be endpoints, they're going to be dots. They're not going to be sloping down the other side. Like this isn't going to be sloping down to the right, and this isn't. It's not going to be sloping down to the left because they're endpoints. So I don't care for writing them on there because, like the x value 1, that's these here are the endpoints, and this is somewhere in the middle. So I'm going to put the 1 there, and all I'm going to use these values for is judging what values I put on this side. So hopefully that makes sense. But here, a value that's between 0 and 1, I'm going to put 0.5. And on this side, I'm going to put a value between 1 and 10. So I'm just going to put 5. Because these two points are just going to be dots. If I put them in here, it's going to give me something, but I don't want that. I already know they're going to be dots. They're going to be endpoints. I don't want what they're going to look like on the other side, or this bit of information here will give me what it will look like up to the endpoints. So I don't need to do the endpoints. Okay? But anyway, so if I sub this value in, 0.5 into the derivative, I get a positive value. Therefore, it's going up. And if I sub the 1 in, I get a 0, because that's how we got the 1. We set the derivative to 0, which makes sense, which means that there's no gradient. It's flat. And if I plug the 5 into the derivative, I get a negative number, which means that it's got a downward slope. Okay? So it basically means that if we sort of draw it, it will look something like that. It'll be a maximum. Okay? This graph shape will be the shape of a maximum more than it will be a minimum. Okay? From the information we've gotten, the domain we're working in. So, from this information here, we can say that the points, we're going to find the minimum and the maximum. Now, it goes like this. Therefore, the endpoints are going to be somewhere down here and somewhere down here. Therefore, the endpoints will be minimums of some sort. And the at this point, at x equals 1, it'll be a maximum. Okay? So, at x equals 1, derivative will be a half. Therefore, there is a max at 1 and a half. So you go across 1 and up a half. And the minimums are at the endpoints. And the endpoints are 0, which would just be 0, 0, which is a good place to start, and 10, and this decimal down here. So x equals 10, and I'm just going to write 0.2. I'm just going to write 0.29. Like you shouldn't do that. You should do it like significant figures or whatever you're working with, but I'm just going to put it like that because this is just a video on how to do it. Okay, so we know that there's a maximum at this point and there's a minimum at this point and this point, because they're endpoints, so they'll have circles. Okay, so we draw a graph with these values in that shape. Okay, so we're going to have a graph this is going to be our fx values, and this is going to be our x values. You could have y here, doesn't matter. And our maximum value is 1 for, maximum value is a half for the height, so 0.5, which is half, and we'll have 1 up here. And we'll have 5. We'll have 10 because 10 is our maximum x value. We won't worry about the negative values because it doesn't matter because we're not going to have anything possibly in the negative area. A negative x area. Okay? So 0, 0 is at x equals 0, 0 is the starting point. It's going to be here. And you're going to draw a circle which signifies that's the end point. And it's going to come up to a maximum at 1.5. So come across 1 and come up a half, which will be about here. And it'll come down to a minimum at 10, and it'll go up about 0.3 or so. So it'll be about, I think, here. So it's going to, and that's going to be an end point as well. So it's going to come up. It's going to head down. And that maximum, that's not that shape, but that's a maximum. And so here, we can say that this point is higher than this point. This point is lower than this point, therefore this is the absolute minimum. And here is the local minimum. I explained a bit on local minimums and local maximums in the last video. And here is the absolute maximum. Remember, it doesn't matter how high the maximum is compared to everything else. If it's the only maximum, it has to be the absolute maximum. It has to be the biggest maximum because it's the only maximum. Although when you have these two, you have two minimums, so you can sort of be picky. This one is lower than this. This has this is at a lower point than this is. Therefore, this is the lowest point, lowest minimum on the whole area we're looking at. And this is not the lowest or the highest, but it's just not. So once you have your absolute minimum, all the rest are local minimums. Okay? Because you can't have two absolute minimums, because absolute minimum means it's the absolute lowest point. Okay? So that's our absolute lowest point. So these, if you're doing an answer on a test, that would be probably your answer. And then you would use a graph like this to find where your absolutes and minimums are. You could use the data if you wanted to, but this just makes it easier. And this is how the actual graph looks. So I'm not going to draw like I did last episode with the actual graph, because this is how it looks. But anyway, I've gone on too long. That's it. Hope you learned something. Thanks for watching, and have a good day.